Starting with the word YABADABADOO, we want to answer the following questions. First, how many arrangements of the string are there? This is another way of saying how many words can you make from those letters. Well, there's 11 total letters, 4 A's, 2 B's, 2 D's, 2 O's, and 1 Y. So we have 11 factorial over each of the counts factorial. So 4 factorial, 2 factorial, 2 factorial, etc. Okay. Now we want to see how many have all the A's together. So in order to figure that out, you're going to treat all the A's as just one A. Okay. So pretend like we threw out 3 of the A's and now there's only one A. That changes how many letters there are. There's going to be 8 total letters. There's 2 B's, 2 D's, and 2 O's. So that's why we're dividing by 2 factorial 3 times. How many have all the A's separated? Well, if we have all the A's separated, it looks something like this. There's 8 total spots where the A's can go, and there's only 4 A's. So there's going to be 8 choose 4 ways to rearrange the A's. But now we have to consider the rest of the letters like Y, B, D, and O. Well, for those, there's 7 total letters, and that's going to be 7 factorial over 2 B's, 2 D's, and 2 O's. So those 2 factorials 3 times. That's the number of ways we can arrange those letters. So to combine that, we take 8 choose 4 and multiply it by 7 factorial over 2 factorial times 2 factorial times 2 factorial. How many don't have an A in the first position, don't have a B in the second position, and don't have a D in the third position? In order to do this, we have to define sets U, V, and W. So we're going to say, let U be the set of words that start with A, V be the set of words that have B in the second position, and W be the set of words that have D in the third position. So keep in mind, we're looking for how many don't have A, B, and D in the respective positions. But we're defining U, V, and W to be the set of words that have A, B, and D in those positions. So those are going to be the opposites. So to write this in set notation, what we're interested in is the complements of U, V, and W, the intersection of the complements of U, V, and W. Now, this looks very complicated. So to simplify what this is, we have to consider the Venn diagrams. So if we have U, V, and W, the complement of U is going to be everything that is not U. And everything that's not U, I'm going to call it 1. Everything that's not V is going to be 2. Everything that's not W, I'm going to label it as 3. Now we're looking for the intersection. So where do 1, 2, and 3 intersect? Well, that's going to be outside of U, V, and W. So what this is it's basically saying it's everything. So when I say everything, it's literally everything inside this box except the union of U, V, and W. And this is what's inside the parentheses. So it's everything except the union of U, V, and W, which the union of U, V, and W is this. And then now I just distributed the minus sign. So we have to figure out what each of those terms are. So first, let's look at U. Say U was every word that starts with A. Well, if you start with A, there's 10 letters left. There's 3 A's, 2 B's, 2 D's, and 2 O's left. So that's going to be the number of ways you can rearrange that. For set V, now you still have 10 letters to choose from. Also, I should add that set W is going to be the same as set V. And the reason is because they both have 10 letters to choose from. V has 4 A's, 2 D's, and 2 O's. versus D has 4 A's, 2 B's, and 2 O's. So they both are going to be the same mathematically because you have 10 letters to choose from, so it's 10 factorial. Then it's 4 A's, 4 factorial. Then here you don't care if it's 2 D's or 2 B's. Basically, it's just 2 factorial, then they both have 2 O's. That's another 2 factorial. Similarly for V intersect W and V intersect D, or V intersect W and, sorry, U intersect V, U intersect W, it's going to be the same case because here you have 3 A's, 2 D's, 2 O's, and this is 3 A's, 2 B's, and 2 O's. So by the same reasoning, you have 9 letters to choose from, 3 factorial, 2 factorial, and 2 factorial. Now we look at V intersect W. There's going to be 4 A's and 2 O's. There's only be 1 B and 1 D left over. So that's why we have 9 factorial over 4 factorial times 2 factorial. Finally, we can figure out what U intersect V, U intersect W is. Well, there's 3 A's, there's 1 B, 1 D left over, and then there's 2 O's. So there's 8 letters to choose from because we have 3 here, and there's 3 A's and 2 O's. So that's why it's A factorial over 3 factorial times 2 factorial. So now we can bring everything together. We figured out each of these terms, and the total was what we originally had. Like, that was the first question. So we just replace everything, and I'm not going to bother to simplify. This is going to be the final answer.